Hello, good evening, my dear students. Welcome to the class. Myself, Bhagyashree Joshi from Sankalp Learning Solutions. In the last class, we have discussed about the light reflection and refraction. What do you mean by reflection? What is light and properties of light, and reflection in case of plane mirrors and reflection in case of spherical mirrors, that is concave and convex mirrors. And also we discussed some multiple choice questions. Yes or no? Okay. Yes. So in this question, so in the class we have solved some multiple choice questions. In that, the focal length of a lens is plus 0.50 meter. Okay. So yesterday I have told you this is concave mirror. Actually, that was my mistake. So sorry for that. It is convex mirror. See, if you get P is positive, then it is a convex lens. Okay. And if it is negative, then it is concave. But here it is positive. Therefore, it is convex lens. Make it convex lens. Okay. So that was my mistake. Sorry for that. Okay. Next one. And also we saw some multiple choice questions and also some problems. In today's session, we are going to discuss next part, that is laws of reflection of light. So this is one of important concept, and this question can be asked for 2 marks. Okay, laws of reflection of light. So laws of reflection of lights are the angle of incidence is equal to the angle of reflection. This is first law. The incident ray, reflected ray, and normal to the mirror at the point of incidence all lie in the same plane. Okay. So incident ray, reflected ray, and normal to the mirror at the point of incidence all lie in the same plane. This is second law. This is first law and this is second law. The incident ray and the reflected ray lie on either side of the normal. So here you can see. Yes. So this is incident ray. Incident ray means what? Coming ray. Okay. So incident ray, when you take a plane mirror or you can take any smooth surface, then it falls on the smooth surface. After falling on the smooth surface, what will happen? It reflect, right? So it reflect. That ray we call it as a reflected ray, and this is in this direction. Yes or no? Reflected ray. Now, if you draw one normal here, okay, one normal. So in other words, this is a smooth surface, okay, and here incident ray is there, and after incident, then it is reflecting. It is reflected ray. This is incident ray. If you draw one normal, then here it makes an angle with the normal, that is incident ray and angle and normal. So the angle between incident ray and the normal, we call it as the angle of incidence, that is angle I, and the angle between the reflected ray and the normal is angle of reflection, that is angle R. Always angle I is equal to angle R for smooth surface. So it is called as regular reflection. Okay, ಏನಂತ ಹೇಳ್ತೀವಿ ಇದನ್ನ? Regular reflection. Okay, so first law is angle of incidence is equal to the angle of reflection. The incident ray, reflected ray. See, this is incident ray and reflected ray and the normal all lie on the same plane. Okay, ಒಂದೇ plane ಅಲ್ಲಿ ಇರುತ್ತೆ. See, this is regular reflection. So regular reflection ಅಲ್ಲಿ ಏನಿರುತ್ತೆ? I is equal to R ಇರುತ್ತೆ. But irregular reflection, you see, if surface is rough, okay, see for example, if we consider one wooden table, or if we consider one paper, that paper is a rough surface. ಅವಾಗ ಏನಾಗುತ್ತೆ? When this is incident ray, ಒಂದು ray ಬಂದು ಅಲ್ಲಿ ಟಚ್ ಆಗುತ್ತೆ. So after reflection, where it goes, so ಏನಾಗುತ್ತೆ? ಈ ತರ ಎಲ್ಲಾ ಕಡೆ ಅದು ಏನಾಗುತ್ತೆ? ಸ್ಕ್ಯಾಟರ್ ಆಗುತ್ತೆ. ಸೊ ಎಲ್ಲಾ ಕಡೆ ಅದು ಸ್ಕ್ಯಾಟರ್ ಆಗುತ್ತೆ. ಆವಾಗ ಕರೆಕ್ಟ್ ಆದ ಒಂದು ಇಮೇಜ್ ಫಾರ್ಮ್ ಆಗೋದಿಲ್ಲ. ಸೊ ಇನ್ ದಟ್ ಕೇಸ್, ಆಂಗಲ್ ಆಫ್ ಇನ್ಸಿಡೆನ್ಸ್ ಅಂಡ್ ಆಂಗಲ್ ಆಫ್ ರಿಫ್ಲೆಕ್ಷನ್ ಆರ್ ಡಿಫರೆಂಟ್. ಸೊ ಹಿಯರ್ the incident ray and reflected ray and the normal to the mirror are at the point of incidence, all lie in the same plane. The incident ray and the reflected ray lie on either side of the normal. Okay. This is about the laws of reflection of light. Next one. Spherical lenses. So spherical lenses. What do you mean by spherical lenses? The transparent material bounded by two surfaces, which one or two surfaces are spherical. Here, ಎರಡೂ surfaces spherical ಆಗಿರಬಹುದು ಅಥವಾ or one surfaces may be spherical. The material is transparent here. The transparent material bounded by two surfaces, which one or two spherical lenses are concave lens and convex lens. Okay, so here two surfaces are transparent. Okay, remember. Here you can see the concave lens and here you can observe the convex lens. Okay, so this is convex lens and this is concave lens. Types of spherical lenses. So this is concave lens and this is convex lens. Concave lens is like this and convex lens is like this. Okay, next one. Types of lenses. Types of lenses are biconvex lens. Okay, next biconcave lens. So these two surfaces are meant for refraction. Therefore, this is biconcave lens. And here it is plano convex. One surface is like this and one surface is plane. That is plano convex. And this is plano concave. One surface is plane and another surface is concave. That is plano concave. Here, concave convex. So one surface is concave and other surface is convex. Therefore, it is concave convex. Okay. These all are types of lenses. Next one. See, these all are very important. Concave and convex. So this is concave mirror and this is concave mirror and convex lens. Okay, so here in case of concave mirror, what happened? See, this is a concave mirror. This surface is meant for reflection and other surface is coated, right? So now when the ray of lights are coming like this and after reflection, these all rays will meet at this point and this is called as principal focus F, right? So that means this is called as converging mirror. Okay, concave mirror is called as converging mirror. Like that, in case of lenses. Okay, in case of lenses. So here it is a convex lens. Okay. Convex lens. So convex lens alli rays are like this after passing through the optic center. So this is optic center, right? So this is optic center. After passing through the optic center, the rays will meet at this point and here it is a principal focus F. Okay. Now here rays are converging, right? Rays are converging. Therefore, concave mirror is called as converging mirror and concave lens is called as converging lens. Have you got my point? Concave mirror is called as converging mirror and convex lens is called as converging lens. Okay. Now, here, convex lens. So, in case of convex lens, this is a reflecting surface and this is a coated part, right? Now, rays are coming like this. After reflection, where it goes? So, after reflection, they will go like this. That means in this direction, the rays will travel. Hinde hogate. See, ನೀವು ಅದನ್ನೇ ಏನಾದ್ರೂ ಡಾಟೆಡ್ ಲೈನ್ ಇಂದ ರೀಪ್ರೆಸೆಂಟ್ ಮಾಡಿ ಡ್ರ್ಯಾಗ್ ಮಾಡಿದ್ರೆ the rays are appear at point F. What is F? F is a principal focus. That means the rays are appear. So exactly ಅಲ್ಲ appear ಆಗತ್ತೆ ನಮ್ಗೆ ಅಲ್ಲಿ meet ಆಗತ್ತೆ ಅಂತ ನಮ್ಗೆ ಅನ್ಸತ್ತೆ. That is appear to meet. Okay, at this point. Therefore, In case of convex mirror, we call it as a diverging mirror. Convex mirror is a diverging mirror, remember. Okay, next, concave lens. Okay, concave lens. So here concave lens is there. So rays are coming like this. So in case of lenses, both the surfaces are transparent here. Okay. Now rays are coming like this. When it passes through the optic center or after refraction, where the rays will go? So rays will go like this. Go like this. ಈ ತರಹ ಹೋಗುತ್ತೆ. ಎಸ್ ಆರ್ ನೋ? ಈ ತರಹ ಹೋದಾಗ ನಾವೇನ್ ಮಾಡ್ತೀವಿ? ಇಲ್ಲಿ ಮಾಡಿದ ಹಾಗೇನೆ. ಸೊ ನಾವು ಡಾಟೆಡ್ ಲೈನ್ ಇಂದ ರೀಪ್ರೆಸೆಂಟ್ ಮಾಡಿದ್ರೆ at this point rays will appear to meet. Okay, at this point rays will appear to meet. That means concave lens is called as diverging lens and convex mirror is called as diverging mirror. Exactly opposite. Concave mirror is called as a converging mirror. Concave lens is called as a diverging lens. Convex mirror is called as a diverging mirror and convex lens is called as converging lens. Remember, this is very, very, very important. Next comes image formation by a concave mirror. So this is important part in this chapter. The image formation by a concave mirror. Here we are using concave mirror. And now our object is at infinity. Okay, so here is that is AB. Now ಈಗ object na ಎಲ್ಲಿ ಇಟ್ಟಿದೀವಿ? That is in the position of AB. Now the rays are coming like this. ಹೌದಾ? When it touches the reflecting surface, what will happen? They will meet at point F. Yes or no? At point F. That means image will form here. Then if the object is at infinity, then position of the image is at the focus F. So see here, image will form here at focus F and it is highly diminished point size image you will get. And it is real and inverted. That means, what do you mean by real image? The image can be found on the screen. Found in the screen, that is called as real image. And inverted. Inverted means what? Ulta. See, the object is like this, then image is like this. That is inverted. Okay. At point F, you will get when object is at infinity, at point F, image will form. Next one. See, when you place the object beyond C. C means what? Center of curvature. So here, now you are placing your object at point at beyond C. So C ಗಿಂತ ಸ್ವಲ್ಪ ಹಿಂದೆ ನೀವು ಆಬ್ಜೆಕ್ಟ್ ಅನ್ನ ಇಟ್ಟಿದ್ದೀರಾ. ಈಗ ಏನಾಗುತ್ತೆ? Where the image will form, C rays are coming like this and one ray is traveling or one ray is coming parallel to the principal axis. That is, after reflection, where it goes, it passes through the principal focus, right? Next one, another ray is traveling through the center of curvature C. Okay, so after reflection, it goes straight. Okay, so one ray hೀಗೆ ಬರ್ತಾ ಇದೆ, one ray center of curvature ಇಂದ pass ಆಗುತ್ತೆ. That means these two rays will meet at this point. Now image will form here. That means between C and F. So see here, when you keep your object beyond C, then the image will form between F and C. Okay, so between F and C, and the image will be diminished. Diminished means idu kuda chikkadagine kanisate nimge, and it is also real and inverted. That means real and inverted. Inverted means ulta image sigatte nimge illu kuda. Next. So here now you are placing your object is at point C, that is at center of curvature. Now one ray is coming like this and another ray will pass or will go through focus F. Now after reflection it goes like this. Okay, so idenagatte through F hogide alva, it goes parallel to the principal axis. Okay, now both the rays will meet at this point. That means image will form here. That is A dash B dash. AB is our object and A dash B dash is our image. Here when you keep your object at point C, this is very, very important. And this question was asked in the previous year examination. When you keep your object at C, then where you will get image at point C only. And image is of the same size as that of the object, and it is real and inverted. Ad hegiratte? Real and inverted. Now, when you keep the object between C and F. So C is here and F is here. So now our object is at C and between C and F. So AB is our object. ಹೇಗೆ ಬರುತ್ತೆ one ray is coming like this and another one ray ಹೀಗೆ ಬರುತ್ತೆ center of curvature ಇಂದ ಹೋದ್ರೆ ಅದು ಹೀಗೇನೆ ಪಾಸ್ ಆಗುತ್ತೆ. So now one ray is parallel to the principal axis. After reflection it passes through the principal focus F, right? And this ray is passing through the center of curvature and these two lines will meet at this point. Therefore, image will form here, that is A dash B dash. And the size of the image is, so when you place your object is between C and F, then position of the image will be beyond C and it is enlarged. Okay, ನಿಮ್ಮ object ಕಿಂತ image ಏನಾಗಿರುತ್ತೆ ಸ್ವಲ್ಪ ದೊಡ್ಡದಾಗಿರುತ್ತೆ, that is enlarged, and it is also real and inverted, remember. Now at F, now you are placing object at F. F means principal focus. So here one ray is coming, one ray is passing parallel to the principal axis. After reflection it passed through the principal focus, that is through F. Next another ray, center of curvature ಹೀಗೆ ಹೋಗುತ್ತೆ, right? So now where these two rays will meet? At infinity. ಎಲ್ಲಿ meet ಆಗುತ್ತೆ ಅದು? At infinity. That means when you place your object at F, then at infinity you will get your image and it is highly enlarged. ತುಂಬಾ ದೊಡ್ಡದಾಗಿರುತ್ತೆ, highly enlarged, and it is also real and inverted. ಅದು ಕೂಡ ಹೇಗಿರುತ್ತೆ? Inverted ಅಂದ್ರೆ ಉಲ್ಟಾ ಆಗಿರುತ್ತೆ. Real means you can get the image on the screen. ಒಂದು ಸ್ಕ್ರೀನ್ ಮೇಲೆ ನಮಗೆ ತಗೊಳ್ಳೋಕೆ ಸಾಧ್ಯ ಆಗತ್ತೆ, that is real image. Next, between P and F. Between P and F. So here P is pole, okay, so center of the reflecting surface, that we call it as a pole P, and this is principal focus F. So now you are placing the object at between F and P, that is AB is here. Now this is ray ಹೇಗೆ ಬರುತ್ತೆ? ಹೀಗೆ ಬಂದ್ರೆ angle of incidence is equal to angle of reflection. Then when you place between P and F, then image position of the image will be behind the mirror. ಎಲ್ಲಿ ಸಿಗುತ್ತೆ ನಿಮಗೆ? Position of the image will be, so ಹೀಗೆ ಬಂದ್ರೆ the rays will appear, the rays will meet at this point and image will form here, that is behind the screen, and it is virtual and erect, and it is enlarged, virtual and erect. Virtual means what? Behind the screen you are getting, that is virtual, and erect means what? Upright image. So your object is like this, then image is also like this. ಬಟ್ ಏನಾಗುತ್ತೆ, ಇದು ಎನ್ಲಾರ್ಜ್ ಆಗಿರುತ್ತೆ. ಆಬ್ಜೆಕ್ಟ್ ಕಿಂತ ಇಮೇಜ್ ಏನಾಗಿರುತ್ತೆ? ದೊಡ್ಡದಾಗಿರುತ್ತೆ. ಮತ್ತೆ ಸ್ಕ್ರೀನ್ ನ ಹಿಂದ್ಗಡೆ ಸಿಗತ್ತೆ, ಬಿಹೈಂಡ್ ದ ಮಿರರ್, ಬಿಹೈಂಡ್ ದ ಸ್ಕ್ರೀನ್ ಯು ಆರ್ ಗೆಟಿಂಗ್ ದ image. Okay, so that is virtual and erect. Next one, so this is in case of concave mirror, right? Next, position, formation of image by a convex mirror. Now we'll see convex mirror. So convex mirror ಅಂದಾಗ ನಮ್ಗೆ different positions ಬರಲ್ಲ. ಯಾಕೆ? ಬಿಕಾಸ್ ಸೆಂಟರ್ ಆಫ್ ಕರ್ವೇಚರ್ ಇಸ್ ಹಿಯರ್ ಅಂಡ್ ಪ್ರಿನ್ಸಿಪಲ್ ಫೋಕಸ್ ಹಿಯರ್. ಹೌದಾ? ನಮ್ಗೆ ಇಲ್ಲೇನಾದ್ರೂ ನೀವು ಆಬ್ಜೆಕ್ಟ್ ಅನ್ನ ಇಟ್ರೆ ರಿಫ್ಲೆಕ್ಟಿಂಗ್ ಸರ್ಫೇಸ್ ಎಲ್ಲಿದೆ? ಇಲ್ಲಿದೆ. Here only two positions we are getting, that is at infinity and between infinity and pole P. Only these two positions we are keeping our object, right? So when you keep your object at infinity, then where image will form? At the focus F and behind the mirror. So at the focus F and it is behind the mirror. Behind the mirror means it is virtual image, and when it is virtual, then image will be erect. Erect means upright. ಯಾವ ತರ ಆಬ್ಜೆಕ್ಟ್ ಇದೆ ಅದೇ ತರಹ ಇಮೇಜ್ ಕೂಡ ಬರುತ್ತೆ. ದಟ್ ಇಸ್ ವರ್ಚುವಲ್ ಅಂಡ್ ಇರೆಕ್ಟ್, ಅಂಡ್ ಇಟ್ ಈಸ್ ಹೈಲಿ ಡಿಮಿನಿಶ್ಡ್ ಅಂಡ್ ಇಟ್ ಈಸ್ ಪಾಯಿಂಟ್ ಸೈಜ್ಡ್. ಇಲ್ಲೂ ಕೂಡ ಚಿಕ್ಕದಾದ ಇಮೇಜ್, ಪಾಯಿಂಟ್ ಸೈಜ್ಡ್ ಇಮೇಜ್ ಬರುತ್ತೆ. ಬಿಟ್ವೀನ್ ಇನ್ಫಿನಿಟಿ ಅಂಡ್ ಪೋಲ್. ನೌ we are keeping our object between infinity and pole P, that is AB is here, AB is the object. Now ಈಗೇನಾಗುತ್ತೆ? Where image will form? Between P and F behind the mirror. So between P and F behind the mirror, that means A dash B dash will form here behind the mirror. Behind the mirror means here also it is virtual and erect and it is diminished. So object kinta tumba chikkadagi kaanatte, that is diminished. Okay. A dash B dash. This is in case of convex mirror. Now, another important point is sign conventions. Okay, sign conventions for spherical mirror. Just we'll have one look over this. So this is new Cartesian sign convention for spherical mirror. Yes, my dear students, what do you mean by Cartesian system? Yes, Cartesian system. Have you heard about Cartesian system? In case of coordinate geometry, Cartesian system will come. So Cartesian system means what? It is XY plane only. So XY plane means what? XY plane means x-axis is there and y-axis is there. So this is x-axis and O x dash and y O y dash. Yes or no? X O x dash y O y dash. So this XY plane we call it as a Cartesian system. Okay. Now this Cartesian system is used for sign conventions in case of spherical mirrors. So spherical mirrors ಹೇಗಿರುತ್ತೆ? So one is like this and another one is like this. So ಹೀಗೇನಾದ್ರೂ ಇದ್ರೆ this is a concave mirror and ಅದೇ ನಿಮ್ಗೇನಾದ್ರೂ ಈ ತರ ಇದ್ರೆ this is a convex mirror, right? So this is a convex mirror. Sign ಹೇಗ್ ಮಾಡೋದು? Where we are using this sign conventions in case of numericals. So ನಾವು ಪ್ರಾಬ್ಲಮ್ಸ್ ಅನ್ನ ಸಾಲ್ವ್ ಮಾಡುವಾಗ ಈ ಸೈನ್ ಕನ್ವೆನ್ಷನ್ ಅನ್ನ ಯೂಸ್ ಮಾಡ್ತೀವಿ. So this is very, very important. ಎಷ್ಟೋ ಮಕ್ಕಳಿಗೆ sign conventions ಗೊತ್ತಿರಲ್ಲ. So this is very, very important. See, this is x-axis and this is y-axis. Now we are considering concave mirror, right? Now, distance towards the right. So distance towards the right idre, that we consider it as a positive. See, ನಮ್ಮ object ಏನಾದ್ರೂ ಇಲ್ಲಿ ಇದ್ರೆ, in case of concave mirrors, always object should be on the left side only. But in case of convex lens ಅಥವಾ concave lens ಇದ್ದಾಗ ನಮ್ಗೆ object right side ಅಲ್ಲೂ ಬರುತ್ತೆ ಅಲ್ವಾ? So distance towards the right is positive and distance towards the left, that means object distance. When you are keeping your object here, that means object distance is negative and image will form here, that means image distance is negative, right? Direction of incident light, direction towards the left, that is negative. Next, height upward is positive, that is erect image, and height downwards, that is inverted image, that is negative. Height upward is considered as positive and height downward, image ಏನಾದ್ರೂ ಉಲ್ಟಾ ಆಗಿದ್ರೆ downward ಅಲ್ಲಿದ್ರೆ, that we considered it as negative. Okay, next, height, ಈಗ ನಮ್ image ಏನಾದ್ರೂ erect ಬಂದಿದ್ರೆ, okay, image, I am talking about the image. So then we are considering it as a positive. If the image is inverted, okay, then this is negative. Remember. So distance towards the right, that is positive. Distance towards the left, that is negative. And the height towards the upward, height upwards is positive and height downwards is negative. So in case of magnification, concave mirror, negative bandre, that is concave mirror. Positive bandre, that is convex mirror. Remember. Next one, image formation in lenses using ray diagrams. Okay, so here lenses are there. This is convex lens, right? Now, image is at infinity. Okay, so when image is, when object is at infinity, when object is here, that means at infinity. Object is at infinity, where you will get your image at point F2, that means focus F2. So when you keep your object at infinity, then position of the image will be at focus F2. Then relative size of the image is, it is highly diminished and point size. So object kinta chikkadada image sigate, that is point size. And nature of the image, this is very, very important. We are talking about the convex lens. Okay, convex lens is called as converging lens. Concave mirror is called as converging mirror, right? So ಅಲ್ಲೂ ಕೂಡ ನಮ್ಗೆ ರಿಯಲ್ ಅಂಡ್ ಇನ್ವರ್ಟೆಡ್ ಬರ್ತಾ ಇತ್ತು. ಇಲ್ಲೂ ಕೂಡ here also we are getting real and inverted, remember. Okay, now beyond 2f1, now we are placing our object beyond 2f1. So here f1 means focus. ಆಮೇಲೆ ಇಲ್ಲಿ ಸೆಂಟರ್ ಆಫ್ ಕರ್ವೇಚರ್ ಸಿ ಅಂತ ತಗೊಳ್ಳಲ್ಲ, f1 2f1, f2 2f2 ಅಂತ ತಗೋತೀವಿ. ನಾವು ಆಬ್ಜೆಕ್ಟ್ ಇಸ್ ಬಿಯಾಂಡ್ 2f1, right? Beyond 2f1. Okay, so beyond 2f1 means position of the image will be between f2 and 2f2. So see here, when the ray is coming like this, after passing through the center of optic center here, the ray will go like this. Okay, one point through optic center hodre ನಮ್ಗೆ ಈ ತರಹ ಹೋಗುತ್ತೆ. Where these two ray will meet at this point, right? That means a dash b dash is our image. This will form between f2 and 2f2, between f2 and 2f2, and it is also diminished and the image is real and inverted. So ulta image ಬರುತ್ತೆ ನಿಮ್ಗೆ. Add 2f1. Okay, add 2f1. Now you are placing the object at 2f1. Where is 2f1? 2f1 is here. So one ray is coming like this and one ray is passing through the optic center O. Now the ray will meet at this point. These two rays will meet at this point. That means image will form here. A dash b dash is the image that is on f2 f2. Image will form at 2f2. So it is same size as that of the object and it is also real and inverted. Next, between f1 and 2f1. So object ಎಲ್ಲಿದೆ ಇವಾಗ f1 and 2f1 ಮಧ್ಯದಲ್ಲಿ ಆಬ್ಜೆಕ್ಟ್ ಇದೆ. ಅವಾಗ ಏನಾಗುತ್ತೆ, one ray is coming like this and one ray is passing through the center optic center O. ಅವಾಗ ಏನಾಗುತ್ತೆ, this line and this ray will meet at this point and image will form here, and this is also inverted. ನಿಮ್ಗೆ ಕೆಳಗೆ ಕಾಣಿಸ್ತಾ ಇದೆ ಅಲ್ವಾ ಇದು? So this is inverted. So ulta image we are getting. So and this is beyond 2f2. ಎಲ್ಲಿದೆ ನಮ್ಮ ಇಮೇಜ್ ಇವಾಗ? Beyond 2f2 ಅಲ್ವಾ? That means beyond 2f2 and it is enlarged. ನೋಡಿ ಇಲ್ಲಿ ಈ ಒಂದು ಇಮೇಜ್ ಗಿಂತ ಈ ಇಮೇಜ್ ದೊಡ್ಡದಾಗಿದೆ. That means enlarged image we are getting. Okay, so ನಮ್ಗೆ ರೇ ಡಯಾಗ್ರಾಮ್ ಅನ್ನ ಡ್ರಾ ಮಾಡಿ ಅಂತ ಕೊಟ್ರೆ ಎನ್ಲಾರ್ಜ್ ಇಮೇಜ್ ಬರೋ ಹಾಗೇನೆ ಮಾಡ್ಬೇಕು. ಓಕೆ, ಸೊ ಇಲ್ಲಿ ನೀವು ಸ್ಮಾಲ್ ಮಾಡಿದೀರಾ, ಈ ತರಹ ನಾವೇನಾದ್ರೂ ಮಾಡಿದ್ರೆ ತಪ್ಪಾಗತ್ತೆ. ಇನ್ ದಿಸ್ ಕೇಸ್ ದಿಸ್ ಇಸ್ ಕರೆಕ್ಟ್, ಬಟ್ ಇನ್ ದಿಸ್ ಕೇಸ್ ಇಟ್ ಇಸ್ ಎನ್ಲಾರ್ಜ್ಡ್. ದಟ್ ಈಸ್ a dash b dash is enlarged. Next one, between focus f1 and optic center O. Okay, now you are placing your object between focus f1 and optic center O. That means here AB is our object, right? Now one ray is coming like this and one ray is passing through optic center O. Optic center O ದಿಂದ ಏನಾದ್ರೂ ಒಂದು ರೇ ಪಾಸ್ ಆದ್ರೆ ಅದೇನಾಗತ್ತೆ, ಅದೇ ಡೈರೆಕ್ಷನ್ ಇಂದ ಹೋಗುತ್ತೆ, ಎಲ್ಲೂ ಅದು ಬೆಂಡ್ ಆಗಲ್ಲ ಅಥವಾ ಮುಂದೆ ಹೋಗಲ್ಲ. ಸೊ ಇದೇ ತರಹ ಸ್ಟ್ರೇಟ್ ಆಗಿ ಹೋಗುತ್ತೆ. Now one ray is like this and one ray is like this. Are they meeting at a point? No. So ನಾವೇನ್ ಮಾಡ್ತೀವಿ, ಹಿಂದೆ ಇದನ್ನ ನಾವು ಡ್ರ್ಯಾಗ್ ಮಾಡಿದ್ರೆ they will appear to meet at this point and this is behind the screen. That is virtual and erect image we are getting. That is enlarged image on the same size, on the same side of the lens as the object. ಲೆನ್ಸ್ ಇಲ್ಲಿ ನಾವು ಆಬ್ಜೆಕ್ಟ್ ಎಲ್ಲಿ ಇಟ್ಟಿದೀವಿ ಅದೇ ಸೈಡ್ಗೆ ಇಮೇಜ್ ಬರುತ್ತೆ. ದಿಸ್ ಇಸ್ ಆಬ್ಜೆಕ್ಟ್ ಅಂಡ್ ದಿಸ್ ಇಸ್ ಇಮೇಜ್ ಆನ್ ದ ಸೇಮ್ ಸೈಡ್ ಆಫ್ ದ ಆಬ್ಜೆಕ್ಟ್ ಅಂಡ್ ಇಟ್ ಈಸ್ ಎನ್ಲಾರ್ಜ್ಡ್ ಇಮೇಜ್ ವಿ ಆರ್ ಗೆಟಿಂಗ್. And this is virtual and erect. This is important. When you are getting virtual and erect image, when you are placing the object between focus f1 and optic center O. Remember, this is very, very important. Okay. Next one. Nature, position and relative size of the image formed by the concave lens for various positions. So this is about the concave lens. Now, when object is at infinity, now object is at infinity, illello object ide, then position of the image will be at focus f1. So see here, one ray is coming like this and one ray is coming like this. After refraction it hege hogutte. ಓಕೆ, ಒಂದ್ ಹೀಗ್ ಹೋಗುತ್ತೆ, ಒಂದ್ ಹೀಗ್ ಹೋಗುತ್ತೆ. ಸೊ ನಾವ್ ಅದನ್ನ ಡ್ರ್ಯಾಗ್ ಮಾಡಿದ್ರೆ ನಮ್ಗೆ ಏನ್ ಅನ್ಸುತ್ತೆ, ಈ ಪೊಸಿಷನ್ ಅಲ್ಲಿ these two rays will meet at this point, that is F2, right? Sorry, F1, F1, this is 2F, and here it is F2 and 2F2. Okay, at focus F1 we are getting the image, and it is highly diminished and point size image, and it is virtual and erect. Why it is virtual? Because we are getting the image ಎಲ್ಲಿ ನೀವು ಆಬ್ಜೆಕ್ಟ್ ಅನ್ನ ಇಟ್ಟಿದ್ದೀರಾ ಅದೇ ಸೈಡ್ಗೆ ಇಮೇಜ್ ಬರ್ತಾ ಇದೆ ಅಲ್ವಾ. ದಿಸ್ ಈಸ್ ಅವರ್ ಆಬ್ಜೆಕ್ಟ್ ಅಂಡ್ ಇಮೇಜ್ ಈಸ್ ಆಲ್ಸೋ ಆನ್ ದ ಸೈಡ್ ಆಫ್ ದ ಆಬ್ಜೆಕ್ಟ್, ದೇರ್ಫೋರ್ ಇಟ್ ಇಸ್ ವರ್ಚುವಲ್ ಅಂಡ್ ಎರೆಕ್ಟ್. ಇದು ಕೂಡ ಸ್ಟ್ರೇಟ್ ಆಗಿದೆ, ಇಮೇಜ್ ಕೂಡ ಸ್ಟ್ರೇಟ್ ಆಗಿದೆ, ದಟ್ ಈಸ್ ಎರೆಕ್ಟ್. ಅಪ್ರೈಟ್ ಇಮೇಜ್, ಎರೆಕ್ಟ್ ಮೀನ್ಸ್ ಅಪ್ರೈಟ್, ಇನ್ವರ್ಟೆಡ್ ಮೀನ್ಸ್ ಡೌನ್ವರ್ಡ್, right? So between infinity and optic center O. So in second case we are placing object between infinity and optic center O. That means between focus F1 and optic center O we are getting our image, that is A dash B dash, and it is also diminished and this is virtual and erect. ಇದು ಕೂಡ ನಮಗೆ ಆಬ್ಜೆಕ್ಟ್ ಎಲ್ಲಿದೆ ಆ ಸೈಡ್ಗೆ ಇಮೇಜ್ ಬರ್ತಾ ಇದೆ, ಎಸ್ ಆರ್ ನೋ? and it is also virtual and erect. So this is very, very, very important. Okay, remember. Next one. In the diagram shown below, a light ray is incident on a convex mirror, right? So convex mirror we are using here. Through which point will the ray travel after reflecting of the mirror? So after reflecting ray ಯಾವ side ಹೋಗುತ್ತೆ, ಎಲ್ಲಿ ಹೋಗುತ್ತೆ, in which direction it will travel, right? So now object is here and the ray is coming like this, that is parallel to the principal axis. After reflection where it will travel? Yes, so ಹೇಗೆ ಹೋಗುತ್ತೆ, passing through F ಹೋಗುತ್ತಾ ಅಥವಾ C ಹೋಗುತ್ತಾ, or it is passing through X, X is here, or it is passing through Z. Where it will go? Passing through X, because it is a convex mirror and it is passing through F. ನಾವೇನ್ ಮಾಡ್ತೀವಿ, here it will appear to meet at F, but it is passing through X. So option C is right. Next one. What is the formula for magnification obtained with the lens? Ratio of the height of the image to the height of the object, or double the focal length, the inverse of the radius of curvature, or the inverse of the object distance. Which option is right here? Ratio of the height of the image to the height of the object, that is M is equal to height of the image is H dash and height of the object is H. So this is the magnification. So option A is right. Next. What is the difference between virtual image produced by concave, plane and convex mirror? Okay. So what is the difference between virtual images produced by concave, plane and convex mirror? So answer is the virtual image formed by concave mirror is magnified, and that produced by a plane mirror is of the same size, and that by a convex mirror is diminished. So this is very, very important. ಕಾನ್ಕೇವ್ ಮಿರರ್ ಇದ್ರೆ ಇಮೇಜ್ ಹೇಗಾಗಿರುತ್ತೆ, ಮ್ಯಾಗ್ನಿಫೈಡ್ ಆಗಿರುತ್ತೆ, ದೊಡ್ಡದಾಗಿರುತ್ತೆ, ಅಂಡ್ ದ್ಯಾಟ್ ಪ್ರೊಡ್ಯೂಸ್ಡ್ ಬೈ ಅ ಪ್ಲೇನ್ ಮಿರರ್. ಪ್ಲೇನ್ ಮಿರರ್ ಇದ್ರೆ image and object are of the same size. So this is same size, and that by a convex mirror is diminished. So point size irutte, diminished andre chikkadagirutte. Define optical center of a spherical lens. Answer is optical center of a spherical lens is a point on its principal axis, a ray of light passing through which goes undeviated along its path after refraction. Okay, what do you mean by optic center? See, this is a convex lens, and so this is a principal axis and this is the optic center. When a ray is passing through the optic center, then it goes without deviated its direction. Okay, and it passing through which goes undeviated along its path after refraction. Illi enagutte, deviate agodilla, undeviated along its path after refraction. Okay, this is center of the spherical lens. Next one. An erect image 3 times the size of the object is formed with a concave mirror of radius of curvature 36 centimeter. What is the position of the image here? Yes, what they have given? For an erect image, so erect image they have given. Okay. Erect image idre magnification is positive. If image is erect, then magnification is positive. If image is inverted, then magnification is negative. Remember, okay, if it is positive, then it is erect, and if it is negative, then it is inverted. Okay, now here it is erect. Erect means magnification is positive. So this is 3 times the size of the object is formed with a concave mirror. That is M is equal to 3 for an erect image. 3 times of the size of the object. Okay. So M they have given. M they have given, that is 3. Right? Magnification they have given 3. R radius they have given, radius of curvature 36 centimeter. So R they have given. By using this R, we can find out F. So F is equal to R divided by 2. That is 36 divided by 2 is 18. Now, 18 is the focal length. But here concave mirror is used. So concave mirror is like this, right? When you are using concave mirror, object should be placed in front of the mirror. Object ಎಲ್ಲಿ ಇಟ್ಟಿರ್ತೀರಾ ನೀವು concave mirror ಅನ್ನ use ಮಾಡುವಾಗ, so in front of the mirror, that means left side of the mirror. So left side should be taken as negative. Yes or no? That means focal length should be negative because it is a concave mirror. For a concave mirror, M is equal to, that is magnification, M is equal to minus B divided by U. B is the image distance and U is the object distance. So this is the formula, right? M value we know, that is 3, and minus B divided by U. Now transfer this U to this side, that is minus V is equal to 3U. So V is equal to minus 3U. Okay, now transfer this sign, that is using the mirror formula means 1 upon V plus 1 upon U is equal to 1 upon F. 1 upon V. 1 upon, what is the value of V? V is minus 3U plus 1 upon U is equal to 1 upon F. Now, 3U and U, that means 3U is the LCM here. So here into 1 and here it is into 3. You need to multiply into 1 into 3. So 1 into 1, that is minus 1, because here minus sign is there. Minus 1 plus 1 into 3 is 3 divided by 3 is equal to 1 divided by F value is, that is focal length, that is minus 18, right? 3 minus 1 is 2 divided by 3U is equal to 1 divided by minus 18. 3U is equal to 18 into 2. Okay, do cross multiplication. 3U into 1 is 3U and 18 into 2 is 36, and here minus is there. Therefore, it is minus 36. Now transfer this 3 to this side. U is equal to minus 36 divided by 3. That is 1, 2. 3 ones are 3 twos are. That means U is equal to minus 12. You will get minus 12. Now putting the value of U in equation number 1. So here it is equation number 1. V is equal to minus 3U is there, right? Minus 3 into U value is minus 12. So V is equal to 3 into 12 is 30. Minus into minus, it is plus. Thus, the image is formed behind the mirror at the distance of 36 centimeter. Now it is positive. So positive means virtual image you will get, and it is behind the mirror, right? So behind the mirror means here it is concave mirror. If image is formed here, then it is negative. But ನಮ್ಗೆ ಏನು ಬಂದಿದೆ ಇದು positive ಇದೆ. So positive means it is behind the screen. Therefore, the image is formed behind the mirror at a distance of 36 centimeter. Understood? Have you taken? Shall we move to next question? Yes, next one. A student holding a mirror in his hand directed the reflecting surface of the mirror towards the sun. Okay. He then directed the reflected light onto a sheet of a paper held close to the mirror. Then what should he do to burn the paper? Which type of mirror does he use? And will he be able to determine the approximate value of focal length of this mirror? From this activity, give reason and draw ray diagram to justify your answer in this case. Okay. Yes. So one student idane, avನು ಏನು ಮಾಡಿದಾನೆ, ಒಂದು ಮಿರರ್ ಅನ್ನ ಅವನ ಕೈಯಲ್ಲಿ ಹಿಡ್ಕೊಂಡಿದ್ದಾನೆ. ನೆಕ್ಸ್ಟ್ ಅವನು ಏನು ಮಾಡ್ತಾನೆ, ಡೈರೆಕ್ಟೆಡ್ ದ ರಿಫ್ಲೆಕ್ಟಿಂಗ್ ಸರ್ಫೇಸ್ ಆಫ್ ದ ಮಿರರ್ ಟುವರ್ಡ್ಸ್ ದ ಸನ್. ಆ ರಿಫ್ಲೆಕ್ಟಿಂಗ್ ಸರ್ಫೇಸ್ ಅನ್ನ ಟುವರ್ಡ್ಸ್ ದಿ ಸನ್ಗೆ ಅಂದ್ರೆ ಸೂರ್ಯನ ಕಡೆಗೆ ಬರುವಂತೆ ಆ ಮಿರರ್ ಅನ್ನ ಹಿಡ್ಕೊಂಡಿದ್ದಾನೆ. He then directed the reflected light onto a sheet of paper held close to the mirror. Okay. ಏನ್ ಮಾಡ್ಬೇಕು ಇವಾಗ, ಯಾವ ಮಿರರ್ ಅನ್ನ ಯೂಸ್ ಮಾಡ್ಬೇಕು ಮತ್ತೆ ಪೇಪರ್ ಅನ್ನ ಬರ್ನ್ ಮಾಡ್ಬೇಕಾದ್ರೆ ಏನ್ ಮಾಡ್ಬೇಕು? The student should adjust the distance between the mirror and the paper. Yes or no? So here sun is there. So ಇಲ್ಲಿ ನಿಮ್ಗೆ sun ಇದೆ. So here you are using mirror. Okay. So ಇಲ್ಲಿ ನಿಮ್ಗೆ rays ಬರ್ತಾ ಇದೆ. So the student should adjust the distance between the mirror and the paper. So the solar rays are sharply focused on the paper. ಅವನು ಏನ್ ಮಾಡ್ಬೇಕು, ಡಿಸ್ಟೆನ್ಸ್ ಅನ್ನ ಅಡ್ಜಸ್ಟ್ ಮಾಡ್ಬೇಕು. ಇಲ್ಲಿ ಒಂದು ಪೇಪರ್ ಅನ್ನ ಹಿಡ್ಕೊಂಡಿದ್ದಾನೆ. The mirror is a concave mirror. Okay. The student can find approximate focal length. 1 minute. Yes, the mirror is concave mirror and the student can find approximate focal length by measuring the distance between paper and the mirror. ಅದನ್ನ measure ಮಾಡಿದ್ರೆ ಅವನಿಗೆ he can find approximate focal length. Okay. Next one. What is meant by the power of a lens? Write its SI unit. A student uses a lens of focal length 40 centimeter and another of minus 20 centimeter. Write the nature and power of each lens. Okay. So what do you mean by power of lens? Yes, power of lens means the ability of a lens to converge or diverge the ray of the light after refraction is called power P. Okay. Power of the lens. It is defined as the reciprocal of the focal length. That means P is equal to 1 divided by F. F is the focal length and power is the reciprocal of focal length. That is 1 divided by F. The SI unit of the power of a lens is diopter. Remember, this is very, very important. Diopter. SI unit of the power of a lens is diopter and it is denoted by the letter capital D. A lens of focal length 100 centimeter has a power of 1 diopter. That means 1 per meter. Okay. So next, a student uses a lens of focal length 40 centimeter. Focal length 40 centimeter and another of minus 20 centimeter. That means two focal lengths are there. One is 40 centimeter and another one is minus 20 centimeter. One will take as a FA and another will take as a FB. Okay. So ಒಂದನ್ನ FA ಅಂತ ತಗೊಳ್ಳೋಣ, ಮತ್ತೊಂದನ್ನ FB ಅಂತ ತಗೊಳ್ಳೋಣ. So FA is 40 centimeter plus 40 centimeter and the another one is minus 20 centimeter. Now write the nature and power of each lens. Okay. Nature and power of each lens. So in order to find out the power of a lens, P is equal to 1 divided by F. So here focal length of the FA, that means PA will consider PA is equal to 1 divided by FA, that is 1 divided by 0.4, that is 40 centimeter. If you convert it into meter, then divided by 100, that is 0.4. 1 divided by 0.40, that is 2.5 diopter. So it is positive, right? Positive 2.5 plus 2.5 diopter. D is diopter. Power of lens B, that is PB is equal to 1 divided by FB. So here 20 centimeter and if you convert it into meter, then it is 0.20 0. Here it is negative, therefore it is minus 0.20. So 1 divided by minus 0.2 is minus 5 diopter. So observe here, this is PA is plus 2.5 diopter and PB is minus 5 diopter. So plus sign is there, minus sign is there. That means the nature of the lens A is convex with power plus 2.5. When you are getting positive sign, then it should be a convex lens. Okay, convex. Okay, next. Here it is negative. When it is a negative, that means when power is negative, then it is a concave lens with power minus 5D. Okay, this is concave. Positive means it is convex, negative means it is concave. Remember. Okay, understood? Next one. The magnification. This question was asked for 4 marks. What is the question? The magnification of an image formed by a lens is -1. So magnification that they have given, that is -1. If the distance of the image from the optical center of the lens is 25 centimeter, where is the object placed? Okay, we want to find out. Find the nature and the focal length for the lens if the object is displaced 15 centimeter towards the optical center of the lens. Where would the image be formed? Draw a ray diagram to justify your answer. Okay. Yes. So when you are getting minus, that means magnification is minus, that means this is a real image. Yes or no? Magnification enadru minus idre, that is negative, means it is real image. Right? So for real image, m is equal to 1. Therefore, m is equal to minus u divided by v is minus 1. So u is equal to minus p. So u divided by v is equal to minus 1. So if you transfer this v to this side, then u is equal to minus v or v is equal to minus u. Minus u is equal to v. That means focal length they have given, that is 25 centimeter. Okay. 25 centimeter. Minus 25 centimeters. So when image is real, then it is minus 25. Now by using the lens formula, 1 upon f is equal to 1 upon v minus 1 upon u. 1 upon f is equal to 1 upon v, that is 25. Okay. Minus 1 divided by minus 25. U is minus 25, right? So 25, 1 plus minus into minus, it is plus. So 1 plus 1 is 2 divided by 25. 1 divided by f is equal to 2 divided by 25. Therefore, 2 divided by 25 is 1 divided by 12.5. Okay. So f value is 1 divided by f is 1 by 12.5. Then what is the value of f? F is 12.5 centimeter. Thus, the positive focal length shows that given lens is a convex lens. Okay, here f is positive. Therefore, it is a convex lens of focal length 12.5 centimeter. If the object is now displaced, so see here, if the object is displaced 15 centimeter towards the optical center, so 15 centimeter now displace ಮಾಡಿದೀವಿ. So if the object is now displaced 15 centimeter towards the optical center of the lens, that is object is now placed at a distance of, first it is 25 centimeter. Now we are displaced to 15 centimeter. So 25 minus 15 is 10 centimeter from the optical center. Now u is equal to minus 10. Okay, minus 10. F is plus 12.5 centimeter. Now, using the lens formula, 1 upon f is equal to 1 upon v minus 1 upon u, or 1 upon v is equal to 1 upon v plus 1 upon u is equal to 1 upon f. So 1 upon V is equal to 1 upon V, we don't know. U is minus 10, right? So 1 upon F, transfer this 1 upon V to this side, that is plus 1 upon V, 1 upon U. 1 upon V is equal to, what is the value of 1 upon F? So observe here, 1 upon F is 2 divided by 25. This value we will take. 2 divided by 25 plus U value is minus 10 here. So object distance, okay. So this is convex mirror. Now object is here, that means left side, therefore it is negative. So minus 10. 1 divided by minus 10. 2 divided by 25, plus into minus is minus 1 divided by 10. Okay, 25 and 10, LCM is 40. So 50 twos are into 2. 10 5s are 50 into 5. 2 2s are 4, 1 5s are 5. 1 divided by V is equal to 4 minus 5 divided by 50. So 1 by V is equal to 4 minus 5 means it is minus 1 divided by 50. Yes or no? 1 by V value is minus 1 by 50. Then what is the value of V? V is equal to minus 50 centimeter, right? Now here it is minus. Minus means what? It is virtual image. So in this case, virtual image is formed on the same side as that of the object at a distance of 50 centimeter from the optical center of the lens as shown in the figure. So observe here. Now this is a convex lens. Now object is here. That means left side of the lens. That we consider it as a negative. Therefore, it is minus 10. Okay. Object illide. ಅದಕ್ಕೆ ನಾವೇನ್ ಮಾಡಿದೀವಿ ನೆಗೆಟಿವ್ ಆಗಿ ತಗೊಂಡಿದೀವಿ. ಸೊ ಇವಾಗ ರೇ ಡಯಾಗ್ರಾಮ್ ಅನ್ನ ನಾವು ಡ್ರಾ ಮಾಡಿದ್ರೆ ಹೇಗಾಗತ್ತೆ? Now one ray is passing through here and one ray is passing through the optic center. ಆಮೇಲೆ ಏನಾಗುತ್ತೆ? ಎಲ್ಲಿ ಮೀಟ್ ಆಗುತ್ತೆ ಈ ಟೂ ರೇಸ್? At this position. That means the same side as that of the object. So ಈ object ಎಲ್ಲಿದೆ ಆ side ಅಲ್ಲೇ image ಕೂಡ form ಆಗುತ್ತೆ. That is enlarged and it is virtual image. So virtual image. Object ಅನ್ನ ನಾವು ನೆಗೆಟಿವ್ ಆಗಿ ತಗೊಂಡಿದೀವಿ. That means object is on the left side. Now image is also on the left side. Yes or no? Image is also on the left side. ಅದಕ್ಕಾಗಿ ನಮ್ಗೆ V ಎಷ್ಟು ಬಂತು? minus 50. So minus means what? It is image is also on the left side or as that of the on the same side as that of the object. Okay. So therefore it is meters. Image is formed on the same side of the object at a distance of 50 centimeter from the optical center of the lens as shown in the figure. This is the ray diagram. This is F1, this is 2F1, this is F2 and this is 2F2 and this is optic center O. F1 means what? Principal focus. So this is 2F1. This is principal focus. So one lens, there are two focus. Okay. Rays ಹೀಗ್ ಬಂದ್ರೆ ಇಲ್ಲಿ ಮೀಟ್ ಆಗುತ್ತೆ, ಹೀಗ್ ಬಂದ್ರೆ ಇಲ್ಲಿ ಮೀಟ್ ಆಗುತ್ತೆ. Therefore it has two principal focus. So F1, F2 ಅಂತ ಹೇಳ್ತೀವಿ ಅದನ್ನ. Understood? Next question. State Snell's law of refraction of light. Express it mathematically. Write the relationship between absolute refractive index of a medium and speed of light in the vacuum. So Snell's law. Snell's law. The statement of the Snell's law is the ratio of the sign of angle of incidence to the sign of angle of refraction is always constant. Remember, sign of angle of incidence is sin I divided by sign of angle of refraction is sin R is always constant. Okay, that is n to 1. So mathematically it is sin I divided by sin R is constant. The constant n to 1 is called as a refractive index. Okay. Of the second medium with respect to the first medium. N to 1 means what? Second medium with respect to first medium. N1 2 means what? First medium with respect to second medium. Okay. Now, absolute refractive index of the medium is given by Nm is Nm means refractive index, speed of the light in vacuum divided by speed of the light in medium, that is C divided by nu. Speed of the light in vacuum divided by speed of the light in the medium, that is nu. C divided by nu. Remember, this is very, very important. Next one. State the position in which a concave mirror produces a magnified image of a given object. List two differences between the two images. Okay. Now, my dear students, ನಮಗೆ ಈ ತರಾನು ಕೇಳಬಹುದು. ಎಲ್ಲಾ ಟೈಮ್ ಅಲ್ಲಿ ರೇ ಡಯಾಗ್ರಾಮ್ ಅನ್ನೇ ಕೇಳ್ತಾರೆ ಅಂತ ಅಲ್ಲ. Sometimes they may ask for a ray diagrams, or they may ask like this also. That means state two positions in which a concave mirror produces a magnified image. ಯಾವಾಗ ನಿಮ್ಗೆ ಕಾನ್ಕೇವ್ ಮಿರರ್ ಅನ್ನ ಯೂಸ್ ಮಾಡಿದಾಗ ಮ್ಯಾಗ್ನಿಫೈಡ್ ಇಮೇಜ್ ಬರುತ್ತೆ. ಯಾವ ಪೊಸಿಷನ್ ನಲ್ಲಿ ಆಬ್ಜೆಕ್ಟ್ ಇದ್ದಾಗ. ಓಕೆ, ಸೊ ಟೂ ಪೊಸಿಷನ್ಸ್ ಇನ್ ವಿಚ್ ಅ concave mirror produces a magnified images are when an object is placed between focus point F and center of curvature, between F and C. This means between F and C. When the object is between F and C, then you will get magnified image. For this position, image is real, inverted, and it is magnified. Real, nature of the image will be real, inverted, and it is magnified between F and C. And the image is formed beyond the center of curvature of the mirror. And where image will form? Beyond the center of curvature of the mirror. When an object is placed between P and focus point F, between P and F of the mirror, for this position, the image is virtual. So when image is virtual between pole P and focus F. Remember, this is also very, very important. Between P and F, the image is virtual. Position of the image is virtual, erect, and magnified. Okay, ದೊಡ್ಡದಾಗಿರುವಂತಹ ಇಮೇಜ್ ಸಿಗತ್ತೆ, ವರ್ಚುವಲ್ ಇಮೇಜ್ ಆಗಿರತ್ತೆ, ಮತ್ತೆ ಎರೆಕ್ಟ್ ಇಮೇಜ್. ಎರೆಕ್ಟ್ ಅಂತಂದ್ರೆ ಉಲ್ಟಾ ಆಗಿರೋದಿಲ್ಲ. ಆಬ್ಜೆಕ್ಟ್ ಯಾವ ತರ ಇರುತ್ತೆ, ಇಮೇಜ್ ಕೂಡ ಅದೇ ತರಹ ಇರುತ್ತೆ. ದಟ್ ಈಸ್, ಬಟ್ ಇಟ್ ಈಸ್ ಮ್ಯಾಗ್ನಿಫೈಡ್. ದೊಡ್ಡದಾಗಿರುವಂತಹ ಇಮೇಜ್ ನಿಮ್ಗೆ ಸಿಗತ್ತೆ. ಓಕೆ, ಅಂಡ್ ದ ಇಮೇಜ್ ಫಾರ್ಮ್ ಬಿಹೈಂಡ್ ದ ಮಿರರ್. ವೇರ್ ಇಮೇಜ್ ವಿಲ್ ಫಾರ್ಮ್? ಬಿಹೈಂಡ್ ದ ಮಿರರ್. ವರ್ಚುವಲ್ ಮೀನ್ಸ್ ಇಟ್ ಈಸ್ ಬಿಹೈಂಡ್ ದ ಮಿರರ್ ಓನ್ಲಿ. ಹಿಯರ್ ಇಟ್ ಈಸ್ ರಿಯಲ್. ಓಕೆ, ಬಟ್ ಹಿಯರ್ ಇಟ್ ಈಸ್ ವರ್ಚುವಲ್, behind the mirror. Okay, if the next one, if the image formed by the mirror for all positions of the object placed in front of it is always virtual and diminished, state the type of the mirror. Draw a ray diagram in support of your answer. Where are such mirrors commonly used and why? Okay, so image formed by the mirror for all positions of the object placed in front of it always form a virtual and diminished. ಎಲ್ಲಿ ನಿಮ್ಗೆ virtual and diminished image ಸಿಗತ್ತೆ? That means in case of convex mirror, virtual ಅಂತ ಬಂದಾಗ ನಾವು convex mirror ಅನ್ನ ಪ್ರಿಫರ್ ಮಾಡ್ತೀವಿ. ಯಾಕೆ? Why? Because image is formed behind the screen. That is behind the screen. Here it is a reflecting surface and image is formed behind the screen. That is virtual image we are getting. So here we are using convex mirror. Now here you can see the ray diagram. It is virtual, diminished. Okay, rays ನಮ್ಗೆ ಈ ತರಹ ಬರ್ತಾ ಇದೆ. ಆಫ್ಟರ್ ರಿಫ್ಲೆಕ್ಷನ್ ಹೀಗೆ ಹೋಗುತ್ತೆ, ವಾಪಸ್ ಹೋಗುತ್ತೆ. ಬಟ್ ನಮ್ಗೆ ಏನ್ಸುತ್ತೆ, ಇಟ್ ಅಪಿಯರ್ಸ್ ಟು ಮೀಟ್ ಅಟ್ ದಿಸ್ ಪಾಯಿಂಟ್ ಅಂಡ್ ಇಟ್ ಈಸ್ ವರ್ಚುವಲ್ ಅಂಡ್ ಇಟ್ ಈಸ್ ಡಿಮಿನಿಶ್ಡ್ ಪಾಯಿಂಟ್ ಸೈಜ್ ಇಮೇಜ್. ಓಕೆ, ನಾ ಇಲ್ಲಿ ಕೂಡ ಆಬ್ಲಿಕ್ ವಿಲಿ. ಸೊ ಆಬ್ಲಿಕ್ ವಿಲಿ ಅಂತಂದ್ರೆ ಓರೆಯಾಗಿ ಬಿದ್ರೆ ಅವಾಗ ಏನಾಗುತ್ತೆ, ಅದೇ ಡೈರೆಕ್ಷನ್ ಅಲ್ಲಿ ವಾಪಸ್ ಬರುತ್ತೆ. ಹಿಯರ್ ಆಂಗಲ್ ಆಫ್ ಇನ್ಸಿಡೆನ್ಸ್ ಇಸ್ ಈಕ್ವಲ್ ಟು ಆಂಗಲ್ ಆಫ್ ರಿಫ್ಲೆಕ್ಷನ್. ರಿಮೆಂಬರ್, ಐ ಇಸ್ ಈಕ್ವಲ್ ಟು ಆರ್. ಓಕೆ, ನಾವು ಇಮೇಜ್ ಎಲ್ಲಿ ಸಿಗತ್ತೆ ನಿಮ್ಗೆ? ಈ ಪೊಸಿಷನ್ ಅಲ್ಲಿ ಇಮೇಜ್ ಸಿಗತ್ತೆ. ಹಿಯರ್ ಆಲ್ಸೋ ಇಟ್ ಈಸ್ ವರ್ಚುವಲ್ ಅಂಡ್ ಡಿಮಿನಿಶ್ಡ್. A convex mirror is commonly used as a rear view mirror in vehicle. Okay, so where are such mirrors are commonly used and why? So in vehicles, in rear view mirrors, we are using convex mirror. Why? Because it always produces a virtual and erect image whose size is smaller than the object. ಹಿಂದೆ ಒಂದ್ ದೊಡ್ಡ ಬಸ್ ಬರ್ತಾ ಇದ್ರೆ ನಿಮ್ಮ ಮಿರರ್ ಅಲ್ಲಿ ಅಷ್ಟು ದೊಡ್ಡದಾಗಿರೋ ಬಸ್ಸನ್ನೇ ಕಾಣಿಸುತ್ತಾ? ಇಲ್ಲ, ಚಿಕ್ಕದಾಗಿರೋ ಬಸ್ ಕಾಣುತ್ತಲ್ಲ. ಬಟ್ ಬಸ್ ಪೂರ್ತಿ ಕಾಣುತ್ತೆ, ಬಟ್ ಚಿಕ್ಕದಾಗಿರೋದು ಕಾಣುತ್ತೆ. ಫಾರ್ ದ್ಯಾಟ್ ರೀಸನ್ ವಿ ಆರ್ ಯೂಸಿಂಗ್ ಕಾನ್ವೆಕ್ಸ್ ಮಿರರ್. Therefore, it enables the driver to see a wide field of view of the traffic behind the vehicle in a small mirror. So, in that condition, for this reason, we are using convex mirror. Okay. Yes, dear students, today we solved some 2 marks questions, and also we discussed about the ray diagrams. Okay, image formation in concave, convex, lens, and mirrors. Okay. So shall we stop today's session? Types of lenses, laws of reflection. Okay. Angle of incidence is equal to angle of reflection. If surface is smooth, then here it appears regular reflection. If surface is hard, allenadru hard surface idre alli irregular reflection occur agutte. Remember. Okay. So, and also in the yesterday's class we saw some examples, that is some numericals. Okay. Shall we stop today's session? Yes. My dear students, study well. All the very best. Thank you. Thank you so much.